Hi, this is the third playlist in the series where we're looking at past papers. This particular paper is the higher tier calculator paper, and it's paper 3. Now you can follow it if you download the link. It's the Edexcel version. If you download the link in the description below, that'll give you the opportunity to have a go at each of the questions. The whole idea is I'm going to break this whole paper down into about 4 videos of 20 to 30 minutes in length. Please do stop the video, have a go at each of the questions, and then compare your solutions. Okay, so we're going to go on with question number 1, which deals with the area, working out the area of a shaded shape. Okay, so you need to know 2 formulas. The first one is the area of a trapezium, which is the overall shape here, and then you also need to know the area of a circle, which is this shape here. And if you put these 2 semicircles together, it tells you that they are semicircles. If you put these 2 together, you're going to get just one whole circle. Okay, so let's have a look at that then. Area of a trapezium. Okay, well, I would always tend to write the formula down. The way I've been taught it is A plus B times H, where A is this along here, 28, B is 12 along here, and H is going to be 14 along here. So I can work that out, and it is a calculator paper, so I'm going to fill in the numbers, but the actual calculation here, I'm just going to run through my calculator. Now sometimes where I put a little dot here, it just means multiply. Okay, I just think it's a little bit neater, and it makes the video just a little bit clearer. Now if I calculate that, it's going to work out as 280 centimeters squared. Okay, and again then I've got the area of the circle, which the formula for it is pi r squared. Okay, well that's going to be pi. Now just a little bit of a curveball on this one is you've got to remember that they've given you 2 semicircles. Well, if we have a look at that, it means the diameter along here is going to be 6 centimeters, which means that the radius of each of the circles, which is the information I want, is 3 centimeters. Hopefully you can see that okay. So just be very careful when they give you those sorts of dimensions. Okay, so it's going to be pi times 3 squared. If I pop that in a calculator, I'm going to get 9 pi, and if you want to calculate that out, that's absolutely fine. But basically the shaded area is going to be 280, which is the area of the trapezium, minus 9 pi. And if I work that out, that's going to give me 251.725. Now, usually with these sorts of questions, it will ask you to give the answer to a decimal place, or in this particular case, 3 significant figures. So do be careful about that, because you will lose marks if you don't give the answer correctly. Well, if I look at the 3rd significant figure, it's a 1. I'm going to change that to a 2 because there's a number 7 that's after it. Okay, so the answers to this particular question to 3 significant figures will be 252 centimeters squared. Okay, I hope that's all right for you, and let's move on then to question number 2, which deals with conversions. And this particular guy is going on holiday to Turkey, and he's going to convert, and it gives you an exchange rate. Okay, these are really standard questions. You're going to get these in, I wouldn't say every single exam, but certainly you need to be up to speed with these. So please do make sure that you've had a go at this particular question. It's fairly straightforward, or at least the first part is. It says the exchange rate is £1, and for that I'm going to get that amount of lira. Okay, so if I've got 550 lots of £1, I basically need to multiply that number by 550. Okay, so if I just write that, I've got 1 to 3.5601, and that's lira, and this is pounds. Okay, well if I've got 550, I'm going to multiply that by 550. So I need to multiply that by 550, and that will give you, in this particular case, 1958 0.055. Now it does say give the information correct, and again, like a lot of these questions, they do have this extra little bit in them. Give your answers the nearest lira. Well, the nearest lira to that is number 8 there. It's 8 units, so it's going to be 1958 lira in total. Okay, let's move on then to the next question, and you'll see that I tend to answer these questions in kind of ratios, and that's exactly the same sort of way in which you can answer the next bit of question, because what we're saying is that if £2 is the same as, I don't know what the symbol is for lira, I'll just write it, 7 lira, okay, then if he's going to go out and buy a pair of shoes that cost approximately £60, what he's done is he's multiplied this by 30. Okay, so if he's multiplied that by 30 to get to £60, you need to multiply the lira cost also by 30, so that would be 210 lira. So you're showing that the approximate cost of the shoes is £60 and it's 210 lira. Okay, I hope that's all right for you. Again, very typically with these sorts of questions, they'll then ask you to make to state an opinion. Okay, well, what we're saying is using £2 to £7 to 7 lira instead of using that is a sensible start to as if method to work out the cost of the shoes in pounds. Yeah, okay, well, I would say actually it's not fantastically sensible, because he's going to get less lira for his actual pound. So if we say that £2 equals 7 lira, basically is an estimation, okay, but it's actually an underestimate, because actually if he wants to buy £2, it's going to cost him in reality 7.12 lira. Okay, so the shoes themselves will be slightly more expensive than the original sort of estimation method suggests. So it's a bit of an underestimation. It's not a massive one, but it's the kind of questions that they tend to ask to make sure that you've got a good understanding of what this kind of conversions are involved, or what's involved in these conversions. Okay, let's move on then to question number 3, which is a little bit more pure maths, and that deals with the Fibonacci sequence. Okay, and if you're going to do maths at a higher level, then you will come across Fibonacci fairly regularly, and I think also there is some Fibonacci work in GCSE as well. Okay, so what we've got here is the first 6 terms of a Fibonacci sequence, and the rule is the next term in the sequence is the sum of the 2 previous terms. So let's have a look at that. So what we've got here is the first term, second term, third, fourth, fifth and 6th. Now you might remember from a previous video that I'm actually not madly keen on the word terms. I think it's a little bit confusing. I prefer the word place. Okay, so the next place in the sequence is the sum of the 2 previous places. So let's just check that. Well, this is the next place, second place. Well, that's the sum of that one, the previous one, plus 0. So 1 plus 0 is 1. That one is the sum of the 2 previous terms, so that plus that is 2. That is the sum of the 2 previous, 2 plus 1 is 3, and so on. Okay, so if I want to work out the 9th term in the sequence, frankly, it's just probably as easy to actually just carry on and write out the 7th, 8th, and 9th term. It's not asking you to calculate it, it's just asking you to find it. So that'll be 13, 21 and 24, and you can see here that 24 is the sum of 13 and 21, and 21 is the sum of 8 and 13. Okay, so the 9th term in the sequence, in this particular Fibonacci sequence, or in this Fibonacci sequence, is 34. And what we're actually doing then is really, if you look at question B, it's all about the algebra really, because what we're saying is that the first 3 terms of this sequence, this is the first place, second place, third place, okay, and it shows that the sixth place is going to be 3a plus 5b. Okay, well, let's have a look at that then. So I'm just going to repeat that. So first is a, second is b, third is a plus b. Well, remember that the next term in the sequence, the next place, is going to be the sum of the two previous ones. So that's going to be a plus 2b. Okay, the fifth place then is going to be the sum of the two previous places. So if I add those two together, I'm going to get 2a plus 3b, 2a plus 3b. And the sixth term, which is the one that they're after, is the sum of the two previous. So a plus 2a is going to be 3a, and then 2b plus 3b is going to be plus 5b. Okay, so you're showing that the sixth place, or the sixth term in the sequence, is 3a plus 5b. Okay, so let's have a look at that then. Part C, it says, given that the third term is 7, okay, and the sixth term is 29, find the value of A and B. Well, we're told that the third term, the third place, is A plus B. So that means then that A plus B equals 7, okay, and the sixth term, which is the one that we just worked out, is this one, which is 3A plus 5B equals 29. Okay, well, really it's a simultaneous equation. We can just work that out as a simultaneous equation. So what I'm going to do is I'm going to look at this first equation here, and I'm going to multiply it by 3, and if I do that, that will allow me to write this as 3a plus 3b equals 21. Now I've got two equations here that when I take one away from the other, I lose the value of 3a, because don't forget there's two unknowns. I've got an a and a b term. Okay, well, I need to get rid of the a's in order to get this solution and find out, at least in this particular case, the value of the b's. So if I get rid of those two, I've then got 5b minus 3b is 2b, and that's equal to 29 minus 21, which is going to be 8. So I can then work out that if 2b equals 8, if I divide through by 2, b equals 4. Okay, and then it's just really a case of plugging that back in to one of the equations, just the same as you would with any other simultaneous equation. So I can say that a plus b equals 7, and if the value of b is 4, then I've got a plus 4 equals 7. Take 4 away, so a must equal 3. Okay, so in this particular Fibonacci sequence, I've got a equals 3 and b equals 4, and that would answer that particular question. It is a bit of a tricky one. You've got to kind of recognize, I think, that you can solve this simultaneously. If you're not sure about how to solve simultaneous equations, please do have a look at some of the additional videos on the channel, and that will give you quite a lot more examples. Okay, so let's move on then to question number 4. In question number 4, we've got a survey. It's kind of real life maths, where they talk a little bit about, you know, what actually happens in the real world. So we've got the outside temperature and the number of units of electricity for heating were recorded for 10 homes. Scatter graph shows the information. Well, you know, as soon as you see a scatter graph, the best thing to do is draw a line of best fit, because you can actually guarantee that you're going to need to use it. Okay, so it's always a good idea to draw a line of best fit. Okay, now it says, is Molly right to say the number of number of units of electricity used on average decreases by 4 units for each degree C increase in outside temperature? Okay, so is Molly right? Well, basically they're talking about the gradient. So what I can do here is I can say, well, actually, just to make my life easier, I'm going to look at the difference between 5 and 15, and beg your pardon, 5 and 15. So it's actually going to be those 2 units here. Okay, and I'm going to draw a little right angle triangle. Okay, so if I draw a little right angle triangle along here, hopefully this is going to come across okay on the graph. But what it'll show me is the ability then to work out the gradient of this particular triangle. Now you'll remember that gradient is going to be the difference in y divided by the difference in x. So the difference in y is this one here, which in this particular case is going to be 10, 20, 24, yeah, it's actually 24. I think actually on the one that I worked out before it came out as more like 26. Okay, so it's actually going to be the difference in y of 26. You appreciate this is just a video here, so it's a little bit difficult to be able to do this as well as I might want to, and as carefully as I would do, obviously, if I was taking the exam. Okay, so the difference in y, this is the difference in units, okay, and the difference in x is going to be the outside temperature, which is the difference between here and here. And I did that at 10 because it makes my life a little bit easier. So this is outside temperature, okay. So the difference between the two is going to be 10 for the outside temperature for every 26 units decrease in temperature. Now it is a minus graph, it's a graph that goes in the minus direction. Okay, so if I work that through, it means then that it will be 2.6 units per degree of temperature. So actually in this particular case Molly is incorrect. Okay, if I put Molly is incorrect. Okay. Alrighty, I hope that's okay for you. With those, you can be fairly accurate, but because it is a scatter graph and a line of best fit, everybody's graph will be slightly different, and they do give us a variation. I'm not quite sure what it is. If you have a look at the mark scheme, it will give you some idea, but this 2.6, I think before I probably would have got away with 2.4, but I think it was at the lower end. Okay, so then it says you should not use the line of best fit to predict the number of units of electricity used for heating when the outside temperature is 30 degrees C. Give one reason why. Okay, well, I've kind of misdrawn this line of best fit because there's no information about this part of the graph, okay? So I kind of did it deliberately so I could just scribble it out afterwards to show you that actually the reason why we can't make that prediction is because there's just no information. So all you would write in here, one reason is there's no information and that you can't assume past the 30 degrees, so past this information here, past 30 degrees, it will continue. Okay, and that's good enough for that 1 mark on these particular types of questions. Okay, let's move on then to question 5. I'm kind of very conscious of the time. We're on to about 20 minutes now, so if you've been doing each of these questions, you should be spending about 40 minutes, so we're going to carry on just a little bit longer. Okay, so this is question 5. Henry is thinking of having a water meter, and there's 2 ways he can pay for the water he uses. Okay, so in this particular case, it's really just a case of working out the charges. Now I'm going to make an assumption, which sometimes they miss out in these sorts of things, just not to cause any confusion, but I'm going to assume there's 365 days in a year, okay. And every 4 years, obviously, it's a leap year, so there isn't. But in this particular case, I'm going to assume that there is. It doesn't really matter. The result is going to be much the same. Okay, so the total water usage for the water meter example, or the information that we've got, is that he uses 1 cubic metre is 1,000 litres, and he says Henry uses an average of 180 litres of water each day. Okay, well, that means then that the total amount of litres he's going to use is going to be 180 times 365. Okay, so on a typical year he's going to use 65,700 litres. Okay, now just be really careful with these sorts of questions. They are fairly generously marked. It's actually a 5-mark question, but you need to just jump through a couple of loops, because actually the information we're given is it's 91.22p for every cubic metre. And we're also told that 1 cubic metre equals 1,000 litres. Well, we've worked out that he uses that amount of litres. So just be careful to change that to 65.7 cubic metres. Okay, and the way we're going to do that is that we move the decimal point 3 places. We're going to divide by 1,000. So we move it from here 3 places in, and that takes us to 65.7 cubic metres. Okay, so let's have a look then at how much it's actually going to cost him. Okay, well, with the water meter, it's going to cost him the standing charge. It's very, very common with electricity bills and water bills and gas bills to have a standing charge, which is just an amount that, regardless of how much you use, they're going to charge you it anyway. So in this particular case, it's £28.20, and I'm going to add to that the value of the water usage, which is going to be, and again you've got to change this to pounds because we're working in pounds, so it's another sort of justification of the 5 marks for this particular question, that you need to make sure that you don't keep it as pence, you have to change it to pounds. Okay, so move the decimal point twice, and then we're going to multiply that by the cubic meters, 65.7. And if I pop that into my calculator, I'm going to get a total bill at the end of the year of 88.13154. Okay, which I've got to say for water is extremely inexpensive. Okay, so for no water meter, which I'd be quite happy to pay myself, okay, that's going to be £107. Okay, so in this particular case, it's fairly straightforward that Henry should have a water meter. Okay. All right, I hope that's okay for you. They are a fairly easy 5 marks, but you have to make sure that you dot all the I's and cross all the T's and be nice and methodical when you're actually doing your working. Okay, I think on this particular video we're going to leave it there. That's taken us through to about 22-23 minutes, and I think that's probably okay. So we'll have a look at starting the next video. I hope you've done well with this particular series of questions. If you're not sure about anything, please do add a comment below. I'll always come back to you. Subscribe to the site, and I'll look forward to seeing you inside the next video.